Okay, so this is just a recap of what we covered last lesson. So a cubic equation can be written in its general form ax cubed plus bx squared plus cx plus d, but also could be written in its factorised form where we can show what the roots are, and in this case the roots would be alpha plus beta plus gamma. And this leads to the sum of the roots being minus b over a, the sum of the product pairs being c over a, and the product of the roots as minus d over a. And the quartic equation works in a very similar way. So we have the sum of the roots minus b over a, the sum of the product pairs as c over a, the sum of the triple products as minus d over a, and the product as e over a. Let's take a look at an example. A quartic equation has real coefficients and two of its roots are 3i and 1 minus 2i. Now it's important here to note that it says real coefficients, which means a and b are real numbers and not complex. And because of this, this means that the roots here, we can use those to work out the other roots because we should have the complex conjugate pairs for those. So if 3i is one root, then minus 3i is another, and 1 minus 2i implies that 1 plus 2i is also a root, which means we can now find the sum of the roots by adding these together. So 3i plus minus 3i plus 1 minus 2i plus 1 plus 2i. So the first two, they will cancel out, and then we'll be left with minus 2i plus 2i. That also cancels out, gives us a sum of 2. We can then work out the product of the roots as well. So this is 3i multiplied by minus 3i and the other two all multiplied together. So if we take this, do the first two brackets, 3 times 3 is 9, so that's minus 9i squared, and I squared is minus 1, so this would give us 9, and that would be multiplied by those second brackets. So if we multiply those out, that gives us 1 plus 2i minus 2i, that would be minus 4i squared. The middle terms will cancel, and the minus 4i squared, so I squared is minus 1, that would give us plus 4, and 1 plus 4 is 5, so that gives us 45. Now we just need to be careful with the notation that the question has used and the notation that we used to for the sum and the product of the roots. So we would have A, B, C, D and E as the coefficients of that quartic, and so the sum would be equal to minus B over A, and the product would be equal to E over A. So if we use those two, the minus B from the quartic equation, that is an A, and the value of A here is 1, so that is 2 is equal to minus A, so A must be equal to minus 2. So this A refers to the A that we're trying to identify in the quartic. And looking at the second one, so 45, the value of E here is the B in the question, so that's B, and the A that we are talking about is the coefficient of the x to the power 4, which is just 1, so B is equal to 45. Let's take a look at this cubic equation that has roots p, q and r, and use this to find a new cubic equation that has roots 3p, 3q and 3r. So starting with the coefficients of that cubic, so we have a is 1, b is -3, c is 0 and d is 2. We then use these to work out the sum of the roots and the product pairs, PQ, QR, RP, and then the product of the roots as well. So the first one there is minus b over a, which has a value of 3. Next one is c over a, well c is 0, so this must be 0. And the final one is minus d over a, which is -2. Now we can use these to work out the new equation. So if we look at how this affects the new one, so we look at the sum of the new roots 3p, 3q and 3r, and this would give us 3 lots of p plus q plus r, which is 9. Now remember, for the new equation that will be minus b over a. Product pairs, so 3p, 3q, 3q, 3r and 3r, 3p. That gives us 9. We factorise out and then simplify. So we've got the PQ plus QR plus RP, and looking above there, that would be 0. So this would be our C over A. And the final one is multiplying all of those together. So 3P, 3Q and 3R, which gives us 27 PQR, which is minus 54. And that is our minus D over A for our new equation. Looking at the new equation then, as we have this and this value, and we have only whole numbers there, so we can take A to be 1, which leaves B to be -9, C would be 0, and D would be minus 54, and then we can substitute those directly into our new equation. So we have x cubed minus 9x squared, got no x term, minus 54 equals 0. Okay, you might like to have a go at this question on your own before we go through the answers. I've just started off there with a little bit of information, so the coefficients of the cubic term and 3 things that you need to work out from that cubic in order to work out a new cubic equation where the roots are alpha beta, beta gamma and gamma alpha. So take a moment now, you might like to stop the PowerPoint at this stage, go through it, and then we'll have a look at the answers, see if you're right. Okay, so using the coefficients here, I'm going to substitute those in to work out the sum of the roots, product pair sum, and then the product of the roots. So we have, it's -5 there, so that's 5 over 3. C over A will be 1 over 3. And the final one we've got -3 over 3, all negated, so that is 1. Looking at the new equation, so we need now to do exactly the same thing as the previous example. So we've got the new roots, and we need to work out firstly the sum. Which, that one's nice and easy, we can get that from above, that's 1/3. And then the product pairs, so alpha beta, beta gamma, beta gamma, gamma alpha, and gamma alpha, alpha beta. And if you look there, each of those parts of that expression have a factor of alpha, beta, gamma, so we can take that out, alpha, beta, gamma, and then that will leave us with an alpha plus beta plus gamma in the bracket. And so using the values from above, we have 1 multiplied by 5/3, so that's just 5/3. And then the final one is product of the roots, so we've got alpha, beta, beta, gamma, gamma, alpha, and that leaves us with alpha, beta, gamma all squared, and that would be 1. 1 squared is 1. Okay, now each of these terms, so the first one there is minus b over a, the second one is c over a, and the final one is minus d over a. Now this time, when we're looking for that new equation, we're using these three values, and because we've got the fractions, this time I'm going to choose a to be 3, which means that b would be minus 1 and c would be 5, and the final one there we would have to convert that, we'd have to change to 3 over 3 for that value of 1 here, and that would mean that d is equal to minus 3. So when we write out the new equation, that would give us 3x cubed minus x squared plus 5x minus 3 equals 0. Please turn to page 47 and complete exercise 2E.